Hi everyone. So today we're going to talk about how we can use trig to find the area of a regular polygon. So make sure you take out a calculator for this particular problem. The example asks us to find the area of a regular polygon with 9 sides, inscribed in a circle with a radius of 10. So we're going to draw a nonagon. As you've noticed, I've already prepped a circle and chosen 9 dots on the circumference that are equally spaced apart. So I would recommend using a compass also to be more precise. Draw your circle, pick 9 dots equally spaced, and then use a straight edge to be neat about it. And it's good to practice being precise so that you get a better looking figure. Let me fix that. A few more to go. Okay, that looks pretty good. Now we can add in some more segments for the radius. I think 2 might be good, similar to what we did yesterday. And add in 10 for the information here. That's the radius. So the radius of the circle is also the radius of our nonagon. So we're trying to find the area of this shape rounded to the nearest integer. So be careful not to round until the very last moment. And let's add some letters also. So we're going to call this nonagon A, B, C, D, E, F, G, H, I. And call the center O. So this is circle O that circumscribes the nonagon A, B, C, D, E, F, G, H, I. Okay. Now, the key to solving this is that we're going to first find that central angle inside over here. And we had a formula for that. So the measure of angle AOB is 360 divided by the number of sides, in this case it's 9, which is 40 degrees. So this is a 40-degree angle. And the key to doing this was that we're going to use the perpendicular segment that comes from the center. Let's draw it right now. Let's use green. So dropping this apothem, we're going to get these right triangles that will be very important for us. And we also will label this point on the bottom x. So we're going to need to find that length of the apothem OX to find out the area in the future. So let's see. From what we discussed, it's going to be important to find the height and the base of this particular triangle. So we have info of these sides, the 10 and the 10. So the apothem splits that 40 degrees in half, 20 degrees and 20 degrees here. And from seeing that information, we know that this is isosceles. Also the angle on the bottom here is congruent to each other. This is a right triangle, so these angles, actually let's go back a little. We can fill in 70 degrees because they're complementary to 20 degrees. So unlike the previous example of the hexagon, this is not a special right triangle. It is not the 45, 45, 90, nor is it the 30, 60, 90. So the values that we're going to find does not depend on the ratios that we learned. If we had those special right triangles, we want to be precise and use the relationships that we learned from those particular cases. But since we do not, we're going to have to use the trig information that we've become familiar with. So let's label the apothem lowercase a, and we got used to using s for the side length. So let's use s for the side length of one side of the nonagon, which is AB here, and see if we can find some information about one of those right triangles. So remember that the apothem is a perpendicular bisector. So xb here is actually half the length of s. Half s. So make sure your s looks different from your number 5. Now we want to find what this is in terms of the angles. Let's choose, it could be either 20 or 70. Let's choose 20 degrees here. So in terms of 20 degrees, we can solve using the 10, of course, because we have information about that. And let's see how A relates to the 20. So in terms of 20 degrees, 10 is the hypotenuse. A is the adjacent side. So let's use that label. And 1/2 S is the opposite side. So if we were dealing with a trig ratio using A, and of course the 10, which we have the most info about, with the adjacent and the hypotenuse, we're using cosine on that angle, which is A over 10. So in terms of the trig ratios, A equals 10 cosine of 20 degrees. Okay, and then the side that has the half of s involves the opposites, and then we can use the 10 again. So the opposite and the hypotenuse, which is the 10, will be using here sine with opposite and the hypotenuse. Sine of 20 degrees is half of s over 10. So that would be 10 sine 20 degrees equals half s. And if you multiply 2 on both sides, that would give us 20 sine 20 degrees, which is the length of one side of our nonagon, which is s. So we have a couple of ways to do this. One way, so the first way, is to find the area of this nonagon, regular nonagon. We can find the area of this triangle AOB, and there's going to be, like we saw in the previous case, depending on the number of sides we have for a regular polygon, it's going to be n congruent triangles of this type. So since n is 9, we want 9 times the area of triangle AOB. Or the second way, we can find the area of the regular nonagon by using the general formula of 1/2 the apothem times the perimeter. And no matter which way we use, we should still get the same result. So the area of a triangle, so let's actually do that over here. The area of our triangle AOB is half the base times the height. So it's half, the base here is s, which is something that we've already found, and the height is a, which is also something that we already found. So if we were writing the expression, it is half 20 sine 20 degrees and times the 10 cosine of 20 degrees. Put that all in there. Close that parentheses. So if we input this now, is maybe not the best time to use the calculator yet, because we still have to multiply 9 when we were trying to find the area of the nonagon. So let's keep that as an expression. So let's go back to the first method over here. We have now 9 times the 1/2 times the 20 sine of 20 degrees times, let's get this more room by erasing that O for a moment, times 10 cosine of 20 degrees. And now, since we're trying to find a regular nonagon's area, now is the best time to use the calculator. So if you round off too soon, it will affect the final result. If you round, you'll get 289.2544244 in your calculator. And to the nearest integer, that will round to 289. Does not have any units provided, so we're going to write units squared. And that's our answer. All right. Now, if you use the second method, you should still get the same answer. So we already found what S was on the left-hand side over here. So the perimeter, right, is the number of sides times the side length, which is n times S, which in this case is 9 times 20 sine of 20 degrees. And this is actually 180 sine 20 degrees. So if you substituted your expression for the area of the regular nonagon, it would then equal half the Potham, which is 10 cosine 20 degrees. And the perimeter, let's also raise the S to give us some room here, times the 180, parentheses there, 180 sine of 20 degrees. And if you multiply it 1/2 times 10 cosine 20 degrees and the 180 sine 20 degrees, you will get the same decimal expansion as before, 289.2544244. And that again will round to 289 units squared. Okay, so you use trig if when you find your angles, it's not one of those special right triangles, you're going to use trig to find your solutions for the area of regular polygons in general. So use the compass to make neat figures for regular polygons in general, and I hope that helps you for future problems.